Another application of the first order and first degree ordinary differential equations is the finding of the orthogonal trajectories of a given family of curves. If we let f of x, y, z equal 0 be a given one parameter family of curves, a curve that intersects the curves of the given family at right angles. So it's important that we take note of this. Right angles, meaning the angle between the two curves is 90 degrees, is called an orthogonal trajectory of the given family. So there is a family of curve and a curve that intersects those curves of the family at right angles is called an orthogonal trajectory of the given family. So again, if we are given the equation of a family of curves, f of xyz equals 0, so the differential equation of the given family is dy dx equals f of xy. So we differentiate to get this new function right here, wherein it's important to take note that um, we remove the constant, the parameter here of the equation of the family of curves. And so since the orthogonal trajectory intersects the family at right angles, then its slope, remember your lesson, its slope is the negative reciprocal of the slope of the family dy dx. So the slope of the family is dy dx here. So the slope of the orthogonal trajectory is negative 1 over the slope of the given family dy dx, which is f of xy. Diba? If the lines are perpendicular to each other, then their slopes are the negative reciprocals of each other. So if the slope of the family is dy dx, then, or f of xy, then the negative reciprocal of f of xy is negative 1 over f of xy. So we can simplify or we can summarize that procedure into these three steps to find the orthogonal trajectories of given family of curves. So step one, from the given equation, f of xy is equals 0 of the given family of curves, we are to find the differential equation of the family. So that's why we have dy dx equals f of xy. So that is the dE of the family of curves. And again, we have to remember to eliminate the parameter in obtaining the dE of the family of curves during the process. So I hope that you can still remember your lesson on the elimination of the constants here. Then step number two is to obtain the differential equation of the orthogonal trajectories to the family by finding the negative reciprocal of the differential equation in step number one. So if this dy dx right here equals f of xy is the dE of the family of curves, then dy dx equals negative 1 over f of xy is the dE of the orthogonal trajectories, negative reciprocal to each other. And then, once we have the dE of the orthogonal trajectories, we can apply our different methods of solving the dE to obtain a one-parameter family of solutions, thus obtaining the desired family of trajectories. So for example, we are given this problem. We are to find the set of orthogonal trajectories of the family of circles x squared plus y squared equals z squared. And remember, sometimes you will not be given what type of curve is given. So you have to, given these equations right here, you have to be able to identify what family of curves is given. So step number one, what was step number one? We are to differentiate the equation to obtain the dE of the family. So given the equation x squared plus y squared equals c squared, then we find the derivative. So 2x plus 2y dy dx equals 0. 2x plus 2y dy dx equals 0. And so dy dx is equal to negative x over y. So again, this is the DE of the family of curves. That's our goal in step number one. So step number two, we are going to find the DE of the orthogonal trajectories. So dy dx would be the negative reciprocal, so that's negative 1 over the negative of x over y, or that would be equal to the positive y over x. That's the negative reciprocal this time. This is the DE of the orthogonal trajectories. And so once we have the DE of the orthogonal trajectories, we go now to step number three, which is to solve the differential equation. So step three, we solve this DE. So this is a parable. So dy over y equals dx over x, or that's dx over x minus dy over y equals 0, or that would be ln of x minus ln of y equals c. After we have integrated this, simplifying, we have ln of x over y equals c. Let this be c sub 1. And so e to the power of ln of x over y equals e to the power of c sub 1. And so x over y equals to c, wherein c is equal to e raised to the power of c sub 1. And so we have x equals cy. This is now our equation of the family of trajectories, orthogonal trajectories. So our problem was find the set of orthogonal trajectories of the family of curves. And this is our family of trajectories. And so as we can see, the trajectories is a family of straight lines. Okay, the set of orthogonal trajectories of the family of circles x squared plus y squared equals c squared is the family of straight lines the equation y equals, or rather x equals cy. So simply follow the steps, simply follow the procedure. So step number one, differentiate to find the DE of the family of curves. Step number two, find the negative reciprocal to find the DE of the orthogonal trajectories. And then we perform our different methods of solving the DE to find the family or the set of orthogonal trajectories of the given family of curves.